Okay, so we're going to go ahead and try this one. And looking at this one, I can see it's going to be a little different. I do have a cosine inverse of 3/5 in there, but I don't know the cosine inverse of 3/5. So I can't really start off that way. So I'm going to go ahead and start off with sine, just breaking it up. We know what sine A plus B is. Hopefully you still have that written down. Hopefully I still have it written down. So sine of A plus B is this. This isn't sine of A plus B. This is sine of A minus B. Hint, sine of A minus B really, when you do cosine or sine, it really just changes your middle sign. We can talk about why in a second though. Or not, it really does just change your middle sign. So sine and cosine inverse 3/5. Then I'm going to get cosine of my second one. So cosine of tan inverse of 2/3. Minus, again, it really does just change your middle sign. Cosine of cosine inverse of 3/5. And sine of tan inverse of 2/3. Okay, and really the reason it changes your middle sign with the subtracting, because I can look at this as adding a negative, right? If I'm adding a negative and tan inverse is telling me the angle, that means I'm going the other way on my angle. And down here, sine is negative. So instead of adding stuff, this would have been a negative sign, so it would have been subtracting stuff. But really, you can just change signs. Okay, so let's see if we can figure this out now that we got it kind of written out. One of these is pretty easy to figure out. You can probably do this one right away because it is a function of an inverse, so the function and the inverse cancel out, all the operations cancel out, and I'm just left with 3/5. And 3/5 is less than 1, so that is in my domain, so that part's good. So, and I can look at the other ones to check. That's in my domain. Here, my domain is anything, so it doesn't really matter. And this does look familiar. This looks like what we did with some of the inverses. So I'm going to come out here, and I'm going to draw a triangle. And I'm going to say, well, this is going to give me a theta, so I'm going to call this theta. And that theta is saying that my adjacent is 3 and my hypotenuse is 5. I can do Pythagorean theorem and I'm going to find that side is 4. So sine of that cosine inverse, so of that same theta, would be 4/5. Here I can do a different triangle. Not same triangle, different numbers. So again, I can call something a theta. So my opposite will be 2, my adjacent will be 3. Since tan is opposite over adjacent. So 2 squared is 4 plus 2 squared is 9, so 13, so square root of 13. So cosine of that same theta is going to be adjacent over hypotenuse 3 over the square root of 13. Minus sine of that exact same theta, because we already drew it out, would be opposite over hypotenuse. So 2 over the square root of 13. Okay, so we have 12 over 5 root 13 minus 6 over 5 root 13. So I should get 6 over 5 root 13. Probably do want to simplify it, so I'm going to rationalize. So square root of 13, square root of 13. 6 square root of 13 over 5 times 13 should give me 65. And done. So weirder setup, it still worked out.